students, welcome back again to another edition of our tutorial question class with Dr. OJ. Now, in this video, we want to show that A minus C all over B is equal to sine A minus C over 2 sec B all over 2 if A over sine A is equal to B over sine B is equal to C over sine C. Now, how do we go about this? We have done something very close to this in a video sometime in the some days ago. So what this one simply means is that you first of all need to equate A over sine A to 2R. So A over sine A is equal to 2R. What do you have? That will give us what? A will be you got to multiply here 2R sine A. If you do the same thing for B over sine B is equals to 2R, because each of them is equals to 2R. That will be what? B will be equals to 2R sine B. So you do the same thing for C all over sine C is equals to 2R. If you cross multiply, like I just said, you have C equals to 2R sine C. So now, what is now A minus B? A minus C over R. Therefore, A minus C over B will be, our A here is now what? 2R sine A. Then minus our C now is 2R sine C. All over our B is 2R sine B. So which can be written as 2R is common into sine A minus sine C all over 2R sine B. So the 2R down here, we cancel the one up here. So we are now left with what? We are now left with sine A minus sine C all over sine B. So now A minus C all over B is now sine A minus sine C all over sine B. Now, you could correct vividly that sine A minus sine C is talking about different angle formula, okay, of A and C, of sine A and C. So you could now say that since, recall, sine A minus sine C will be 2 cos half into A plus C sine half into A minus C. Yes. So that will now replace what you have there. Therefore, A minus C, therefore sine A minus sine C all over sine B is now what? 2 cos half, can write it like this, A plus C over 2, if you like, sine A minus C all over 2, if you like. So everything all over sine B, okay? Everything all over sine B. So we can now rewrite that sine B. We can rewrite sine B in a form that it will be easier for us to deal with. So we can say, also recall that sine B can be written in a half angle formula. Sine B is sine B all over 2 plus B all over 2. Yes, half of, B over 2 plus B over 2 will give you sine B. B is the same thing as half of B plus half of B. B over 2 plus B over 2. SM is 2. 2 into 1. 1 times BB plus 2 into 1. 1 times BB. So this will be 2B over 2, this is B. So we can write this as, from our sine A plus sine A. Sine A plus A. This will be what? Sine B over 2 cos B over 2 plus cos B over 2 sine B over 2, which will give us what? 2 sine B over 2 cos B over 2. We have learned this before, so we are just trying to implement what we have learned before. Okay, so we now have A minus C over B, which is now what? 2 cos A plus C all over 2 sine A minus C all over 2. Now all over 2 sine B all over 2 cos B all over 2. I hope you are getting that. Hope you are getting that. Now, since at this stage now, since A plus C all over 2 is equals to B all over 2. Do you get that? Can you remember that? How? Okay. Sorry. Equals to 90 degrees minus B all over 2. How do we bring this in? Let me show you how we brought this in. You know, if we say A plus B, even using our Napier's rule, plus C equals to 180 degrees. You know, if I divide through by 2, A plus B plus C all over 2 will be equals to 90 degrees. If I divide by 2, if I divide everything by 2, true. So which means that A plus C all over 2 plus B all over 2 is equals to 90 degrees. Okay, you know. So from here, A plus C over 2 will be equals to A plus C all over 2 equals to 90 minus B all over 2. Okay. So we now replace this by, so you can see how I got this now. I think you have seen how we get A plus C all over 2 to be what? To be 90 degrees minus B all over 2. So now, you call very well that from what we have obtained now, we have in the numerator we have cos A plus C over 2. So we can recall from cofinite functions of sine and cosine, cos A plus C all over 2 is something as sine, 90 degrees minus B all over 2. Yes. And so, which is going to give us what? This is going to give us sine B all over 2. Fine. Okay? Because it's positive. So, just like the other time where we talk about cos 3 theta is equals to sine 90 degrees minus 3 theta. So, we have done something like that in our cofinite functions. So, with this now, this therefore A minus C all over B, which gave us what? Which gave us 2 cos A plus C all over 2 sine A minus C all over 2 can now be all over 2 sine B all over 2 cos B all over 2 cannot be written as A minus C all over B is equal to 2 cos A plus C over 2 is now what? Sine B all over 2 sine A minus C all over 2 all over 2 sine B all over 2 cos B all over 2. Note, we didn't change A minus C all over 2 because it's part of what we are expected to retain in the proof. So we don't need to look for the equivalence of A minus C all over 2. No, we are not concerned about that. We have to retain that. So in this case now, this will cancel this. So we now have A minus C all over B is equal to sine A minus C all over 2 all over cos B all over 2. So, and we can write it as A minus C all over B is equal to 1 all over cos B all over 2 sine A minus C all over 2. Yes. So 1 over cos B all over 2. Anything, 1 over cos, reciprocal of cos is what? Is sec. So this one will be A minus C all over B equals to sec B all over 2 sine A minus C all over 2. So what do we have to find? We have to find that. Yeah, beautiful. Beautiful. So, and finally, you can rewrite it in such a way that it suits the arrangement they give to you. Therefore, A minus C all over B is equal to sine A minus C all over 2 sec B all over 2. So the proof is complete. So with this, we have come to the end of the question. So don't forget to click the notification bell so that each time I upload a video, you'll be daily notified. Thank you.